Okay, good morning to all of you. In this class, we are going to discuss about acceleration in spherical polar coordinate system. In our last class, we have been discussed in detail about velocity in spherical polar coordinate system. That is we found that velocity expression is your r dot er cap r theta dot e theta cap plus r sin theta phi dot e phi cap. So in this class, we are going to discuss acceleration in spherical polar coordinate system. Okay, so let's start. The acceleration will be a equal to rate of change of velocity, right? And the velocity we found how much? R dot e r cap r theta dot e theta cap plus r sin theta phi dot e phi cap, that we are going to substitute over here. Instead of v, we have to substitute this much. Now each and every term are going to be differentiated with respect to t. So here d by dt of r dot er cap, d by dt of r theta dot e theta cap, d by dt of r sin theta phi dot e phi cap. First we have to consider this term d by dt of r dot er cap. Consider the product formula. So first one will be d by dt of r dot, that means r double dot. Previously these things already we have been discussed, that suppose we are going to be consider d by dt of x, that means it will be considered it can be written as x dot. Then d by dt of x dot will be x double dot, right? So here d by dt of r dot will be r double dot er cap, then r dot will be remain there, d by dt of er cap. Next we have to consider this term, and considering the product formula, first d by dt of r will be r dot, then theta dot as usual written e theta cap plus r theta dot d by dt of theta dot will be double dot of theta, right? E theta cap, then plus r theta dot d by dt of e theta cap, d by dt of e theta cap. Okay, next we have to consider d by dt of this one. So first we have to consider d by dt of r dot sin theta phi dot e phi cap written as usual. Then keep r and consider the derivative of sin theta is your cos theta, theta dot phi dot e phi cap written as usual. Then r sin theta, we have to consider derivative of phi dot with respect to t, that means d by dt of phi dot will be phi double dot e phi cap written as such. Now we have to consider d by dt of e phi cap, where r sin theta phi dot will be written as such. So r sin theta phi dot d by dt of e phi cap. Let this is your equation number 5. So in equation number 5, overally one curly bracket, another one curly bracket, another one curly bracket. So 3 curly brackets are there. But here you can see d by dt of e r cap is there, d by dt of e theta cap, d by dt of e phi cap. We have to evaluate. D by dt of e r cap already we have been evaluated here at the time of evaluating velocity of SPCS. We evaluated d by dt of e r cap and we found this much. Now we have to evaluate d by dt of e theta cap, d by dt of e phi cap, because you can see that e theta cap is this much, where theta and phi changes with respect to time, and here e phi cap Sin phi cos phi is there. That means phi will be changes with respect to time. So we have to evaluate d by dt of e theta cap and d by dt of e phi cap. Then we have to substitute these values over here and here. Okay. So first we have to consider d by dt of e theta cap. This much. This one. So d by dt of e theta cap. E theta cap, how much we found? This one. I cap cos theta cos phi, j cap cos theta sin phi minus k cap sin theta has been written over here. This much. Now we have to consider d by dt of this term and this term. Here you can see, first we have to consider derivative of cos theta with respect to t. That means cos theta will be minus sin theta, then d by dt of theta will be theta dot. Cos phi as usual written. Then d by dt of cos phi will be minus sin phi. So here then minus I cap cos theta sin phi phi dot, and then plus d by dt of I cap cos theta into cos phi. Okay, see d by dt of these three terms, here three terms are there, one I cap, one cos theta and one cos phi. So first one is your derivative of cos theta with respect to t, here minus sin theta theta dot. Second term is belongs to derivative of cos phi with respect to t, that is your minus sin phi phi dot. Third term should be derivative of d by dt of I cap cos theta cos phi. Here I not written because we know that I cap is a unit vector and d by dt of I cap will be 0. So this term will be 0, only for that I not written over here. So no need to write itself. Next we have to consider d by dt of these three terms, j cap cos theta sin phi. So derivative of cos theta with respect to t will be minus sin theta. So minus j cap sin theta theta dot sin phi. See d by dt of cos theta is nothing but minus sin theta and theta dot into theta dot. Okay, same thing it has been written. Derivative of cos theta with respect to t is your minus j cap sin theta theta dot sin phi written, plus j cap this one sin phi derivative with respect to t is your cos phi phi dot. Then another term we have to I not written, that was d by dt of j cap cos theta sin phi, because I not written because d by dt of j cap will be 0, so that term will be cancelled out, so I not written. Now consider third one, d by dt of sin theta will be minus cos theta theta dot, k cap is there. Then next term will be d by dt of k cap sin theta, but d by dt of k cap will be 0, so that term will be cancelled out, so I not written. So here you can see that this is belongs to theta dot term, this is theta dot term, this is your phi dot and phi dot. See here three terms are theta dot, this one and this one. So minus theta dot taken common from these three terms, then what we can get, minus theta dot I cap sin theta cos phi, j cap sin theta sin phi, plus k cap cos theta. Okay, then these two terms are belongs to phi dot, and here cos theta also is there. So phi dot cos theta taken outside, we can get minus I cap cos theta, sorry, minus I cap sin phi, then plus j cap cos phi. Okay, here you can see I cap sin theta cos phi plus j cap sin theta sin phi plus k cap cos theta is nothing but E r cap, that we know E r cap is nothing but this one. So instead of this we can write E r cap, right? So instead of this we can write er cap. So minus theta dot er cap phi dot cos theta, and this much is nothing but e phi cap. Already we found here e phi cap minus I cap sin phi plus j cap cos phi. So minus I cap sin phi plus j cap cos phi can be written as e phi cap. Let this is your equation number 6. Now we are going to find out d by dt of e phi cap. So e phi cap, how much we found? This one minus I cap sin phi here plus j cap cos phi, and now we are going to consider d by dt of this term, d by dt of this term. So d by dt of this term means derivative of sin phi with respect to t will be cos phi dot plus d by dt of I cap. I not written because that will be 0. Second term will be d by dt of cos phi will be minus sin phi dot, and another term will be come up, that will be d by dt of j cap, but that term will be 0. D by dt of j cap cos phi, that will be 0 because d by dt of j cap will be 0, so I not written. So here we found d by dt of e phi cap this much minus I cap cos phi into phi dot minus j cap sin phi into phi dot. Let this is your equation number 7. Right, now put the values of d by dt of er cap, whatever we have been evaluated previously, and equation number 6 value and equation number 7 value in equation number 5. So in this equation number 5 we have to substitute the value of d by dt of er cap, d by dt of e theta cap, d by dt of e phi cap carefully, okay, for further simplification. So here you can see that a vector or acceleration vector will be r double dot er cap plus r dot d by dt of er cap, r double dot er cap plus r dot here d by dt of er cap, d by dt of er cap value how much we found, that is your theta dot e theta cap plus phi dot sin theta e phi cap. Same I have been substituted over here, r dot into theta dot e theta cap plus phi dot into sin theta e phi cap. Okay, next this term r dot theta dot e theta cap, r double dot e theta cap written. Okay, these two terms have been written over here. Then r double dot d by dt of e theta cap, r double dot d by dt of e theta cap, d by dt of e theta cap is nothing but this one minus theta dot er cap plus phi dot cos theta e phi cap written over here. So carefully you have to write all the terms, minus theta dot er cap plus phi dot into cos theta e phi cap. Instead d by dt of e theta cap we have been written over here. Now next terms are this one, r dot sin theta phi dot e phi cap, r dot sin theta phi dot e phi cap, r cos theta dot phi dot e phi cap, r cos theta dot phi dot e phi cap, r sin theta phi double dot e phi cap, r sin theta phi double dot e phi cap, then r sin theta phi dot d by dt of e phi cap, r sin theta phi dot d by dt of e phi cap is value is this much minus I cap cos phi into phi dot minus j cap sin phi dot. Same thing has been written over here. So carefully you have to write these terms. Okay, so that implies a vector will be, here you can see r double dot er cap. I just multiplied this r dot with this and this, r dot theta dot e theta cap, then r dot phi dot sin theta e phi cap. Okay, then r dot theta dot e theta cap written. r theta double dot e theta cap written over here. Then r theta dot multiplied with this term and this term. So r theta here minus theta er cap. So this will be minus r theta dot square er cap minus r theta dot square er cap. Then r theta dot phi dot cos theta e phi cap. R cos theta, same thing it has been written. See, r cos theta theta dot phi dot e phi cap. Carefully you have to watch these two steps and write down in your note. Okay. Next, this term has been written as usual, r sin theta phi dot e phi cap. This one. Then r cos theta theta dot phi dot e phi cap written over here. Then plus r sin theta phi double dot e phi cap. Here r sin theta phi double dot e phi cap. This term written over here. Then here you can see phi dot is there. Phi dot can be taken outside, and here minus is there. So minus phi dot can be taken from these two terms outside. It will be minus, here one phi dot already is there. So minus, so here minus, it will be minus r sin theta phi dot taken outside means this will be phi dot square. Okay. And inside the bracket remaining terms are I cap cos phi plus j cap sin phi. Okay. So this is the expression of acceleration, but it is not fully converted to spherical coordinates. So this term, up to this term all are converted, but here you can see I cap j cap is there. That means the fully a acceleration is not converted to spherical polar coordinate. Then what we have to do? Then we have to do something, that we have to remove, or we have to convert this I cap j cap to spherical polar coordinates. How it will be? Carefully you have to watch. Here sin theta er cap plus cos theta e theta cap can be written as I cap cos phi plus j cap sin phi. How it is? Carefully you have to watch. Sin theta er cap value is nothing but this one. I have been written over here. Er cap already we found, right? Er cap value we know. Er cap value is this much. I cap sin theta cos phi, j cap sin theta sin phi, k cap plus k cap cos theta has been written instead of er cap plus cos theta e theta cap. E theta cap value is nothing but this one. I cap cos theta cos phi, j cap cos theta sin phi minus k cap sin theta. Already we know this one. So er cap e theta cap value has been written over here and here, right? Now what we have to do? Carefully you have to watch that this value will be I cap cos phi plus j cap sin phi. How it is? Here easily you can identify. See, it is very easy. Here you can see sin theta k cap cos theta. Here cos theta minus k cap sin theta. So these two terms will be cancelled out. Now we are going to consider I cap terms for this and this. For this will be I cap sin square theta cos phi. Here plus I cap cos square theta cos phi, right? So this will be I cap, if I will take common cos phi, this will be 1 because sin square theta plus cos square theta. So here we found I cap cos phi, right? Next sin theta multiplied with this one, this will be sin square theta. That means j cap sin square theta sin phi, right? Then here plus j cap cos square theta sin phi, right? So here sin square sin phi both are same. So if sin phi taken outside, sin square theta plus cos square theta will be 1. So here j cap sin phi. So we can get I cap cos phi plus here this plus this will be From this term we found I cap cos phi. From this term we found j cap sin phi, right? So sin theta e r cap plus cos theta e theta cap can be written as I cap cos phi plus j cap sin phi, right? So here we have at the end in this expression minus r sin theta phi dot square I cap cos phi plus j cap sin phi. So instead of I cap cos phi plus j cap sin phi, here what we can write? We can write sin theta e r cap cos theta e theta cap. That we are going to do now. That implies A will be this much we found, no? Instead of this one only, instead of this one I cap cos phi plus j cap sin phi, we have to substitute this value. Okay, so here r double dot e r cap, r double dot e r cap, r theta sin r theta theta dot e theta cap, r theta theta dot e theta cap. Same, all the terms I have been written over here, all the terms, nothing changed. Minus r sin theta phi dot square, again minus r sin theta phi dot square also written. Here instead of I cos phi plus j sin phi, written as sin theta e r cap plus cos theta e theta cap, whatever we found this one, right? Now what we have to do? We have to just write all the terms belongs to e r cap one place, e theta cap terms at another place, and e phi cap another place collectively. So here you can see this term is belongs to e r cap, another e r cap is there, another term this one e r cap is there, right? So e r cap taken outside, r double dot, here we can found minus r theta dot square, minus r theta dot square, right? Theta dot square. From this term we can found minus r sin theta phi dot square, sin theta is there. So minus r sin square theta phi dot square, minus r sin square theta phi dot square into e r cap. Now collectively we have to write e theta cap terms. So here one e theta cap term, another e theta cap, here is another e theta cap, here another e theta cap term is there. Okay, so e theta cap taken outside, this r dot theta dot e theta cap, r dot, sorry, here r dot theta dot e theta cap. So this will be same two terms, so it can be written as 2 r dot theta dot. Okay, and here r theta double dot, r theta double dot e theta cap taken outside. Okay, now another term is here minus r sin theta phi dot square cos theta. So minus r sin theta cos theta phi dot square e theta cap, right? Now rest of the terms are belongs to e phi cap. This one, this is one term e phi cap, this is another term e phi cap, this is another term e phi cap, this is another term e phi cap, this is also another term e phi cap, and these two terms already written. So here you can see that r dot phi dot sin theta e phi cap, r dot phi dot sin theta is there, e phi cap taken outside. So these two terms are same, we can write 2 r dot phi dot sin theta. Now these two terms, this one and this one, are same, so we can write 2 r cos theta, theta dot phi dot e phi cap written outside. Next this one r sin theta phi dot phi double dot, r sin theta phi double dot whole into e phi cap. So this is the required expression for acceleration in spherical polar coordinate system. So here we got three terms. One belongs to e r cap, e theta cap, another e phi cap. That means this represents the radial acceleration. Okay, because this is the coefficient of er cap, unit vector along r, right? This is the unit vector along theta. That means, suppose if we are going to consider that, suppose only two dimensional case, a particle is revolving like this, and here theta is changes. So radial acceleration and another is tangential acceleration, e theta cap. So e theta cap, at that time e theta cap will be represent the tangential acceleration, and radial acceleration component will be er cap. So er cap and its coefficient, this is represents the magnitude of acceleration belongs to radial acceleration. This is your magnitude of the acceleration belongs to transverse acceleration. This is your azimuthal acceleration. This component is called as the acceleration along azimuthal angle change, right? So this is all about acceleration in spherical polar coordinate system. Thank you so much for watching this video. In our next class we are going to discuss how these expressions are very much important for different examinations. That means we are going to discuss some questions whatever already asked in the JAM examination based upon these expressions. Acceleration and velocity belongs to spherical and cylindrical coordinate system. This is one question asked in 2022, and this is another question belongs to 2022, and another question 2021. These three questions we are going to discuss, which represents the importance of this acceleration and velocity and acceleration in your cylindrical and spherical polar coordinate system. Thank you so much for watching this video. Thank you.